Okay, so one more student has joined. So the first question which we are starting with today is basically the question which has asked in 2021. So if the real part of the complex number z is equal to 3 plus 2i cos theta upon 1 minus 3i cos theta, theta belonging to 0 comma pi by 2 is 0. So real part of this complex number is 0. What it means? It means that this is a purely imaginary number. So this is a purely imaginary number. Then the value of a little bit of trigonometry also you will need here. Sine square 3 theta plus cos square theta is equal to. So if you just see over here that 1 second, let me adjust the camera. Yeah. So this complex number z is having real part 0. So first of all, you will change this complex number z to a complex form, that is x plus iy form. So right now, if you see here, this complex number z is not in the form x plus iy, because in the numerator also there is 3 plus 2i cos theta, and in the denominator also there is a complex form, that is 1 minus 3i cos theta. So you write it like this, that it is 3 plus 2i cos theta upon 1 minus 3i cos theta. And you multiply with 1 plus 3i cos theta in the numerator and in the denominator. So after doing this, what you will find is 3 plus into 1 is 3. And then this is minus 6 cos square theta. And then we have plus 9i cos theta, of course. And then we have plus 2i cos theta. Okay, so we have multiplied this complex number, term by term. So 3 into 1, then 2i cos theta into 3i cos theta, and then other parts. Now in the denominator, it will be 1 minus 9i square. So I square is minus 1. Okay, we know that I square, iota square is equal to minus 1. So 1 minus 9i square. So it will become plus 9 cos square theta. So first write till here. And if you are facing anything which is you have either forgot or you are not understanding, you can just ask. I will get it clear. So 3 minus 6 cos square theta after you have written this plus 9i cos theta plus 2i cos theta is 11i cos theta by 1 plus 9 cos square theta. So you can write it as 3 minus 6 cos square theta upon 1 plus 9 cos square theta. So this is one part plus I 11 cos theta by 1 plus 9 cos square theta. Now this is in the form of x plus iy. This is x, this is y. So this is x plus iy. Now you can say that if this complex number is having real part 0, then this x is actually 0. This 3 minus 6 cos square theta by 1 plus 9 cos square theta is actually 0. This is what it means. Now equate it to 0 and try to find out what is the value of theta. Or you can also say what is the value of cos theta. T minus 6 cos square theta by 1 plus 9 cos square theta is equal to 0 according to the question, which means that 3 minus 6 cos square theta is equal to 0. As denominator will multiply with 0, it will become 0. So cos square theta is equal to 3 by 6, which is 1 by 2, which means that cos theta is equal to plus minus 1 by root 2. So cos square theta is 1 by 2. Cos theta is plus minus 1 by root 2. So since one more thing is given in the question, that theta is between 0 to pi by 2. This is given here, no? That theta is between 0 to pi by 2. That is in the first quadrant. So obviously the value of cos theta we can't take negative. So acceptable value of cos theta will be there. Acceptable value cos theta is equal to plus 1 by root. Only plus, not minus in the first quadrant. So this implies what will be theta. This means theta will be pi by 4 because at 45 degree cos theta is equal to 1 by root 2. Now we have to just find sine square theta plus cos square theta. So if you find sine square 3 theta plus cos square theta, what we get here is sine square 3 pi by 4 plus cos square pi by 4. Sine 3 pi by 4 is 1 by root 2. So square will be 1 by 2. Cos pi by 4 is also 1 by root 2. So square will be 1 by 2. So this will be 1, which is our answer. Let us come to the next question. Have you written till here? Okay, so I am coming to the next one. If the real part of the complex number one minus cos theta plus 2i sin theta to the power minus 1 is 1 by 5 for theta belonging to 0 comma pi, that is first or second quadrant. Then the value of the integral, so there is little bit of integral also involved here. Then the value of integral 0 to theta sin x dx is equal to 1, 2, minus 1, 0. So basically, our task is to find theta. That is our task. If we will find theta, then we will be able to solve the question. So how to proceed? Let me give you the hint. that how to proceed here, that you have been given 1 by, because it is power is -1, right? So it is 1 by 1 minus cos theta plus 2i sin theta. This is what we have. Now, if we want to find the x plus iy form of this, so it is sort of this, that it is 1 minus cos theta plus iota 2 sin theta in the denominator. And what we will do here is, we will multiply numerator and denominator by its conjugate. That is 1 minus cos theta minus iota 2 sin theta by 1 minus cos theta minus iota 2 sin theta. What is the benefit of multiplying with conjugate? Is that the denominator here will become real. That is the identity a square minus b square will be there, which will make it real. So it will change into x plus iy form. And then from there, you can say that the real part is 1 by 5 and you can find theta. So just give it a try, then we'll discuss. So if you see here, this is 1 minus cos theta minus iota 2 sin theta upon, and this is 1 minus cos theta whole square, and this will be minus iota square 2 sin theta whole square. So this is what will happen, a square minus b square. So this is 1 minus cos theta minus iota 2 sin theta upon 1 minus cos theta whole square, and iota square is -1. So this will be plus 2 sin theta whole square. So this is what we are getting. If we are getting this, then what does it mean? It means that this is 1 minus cos theta upon 1 minus cos theta whole square plus 2 sin square theta. This 2 sin theta whole square is 4 sin square theta. Then minus iota 2 sin theta upon 1 minus cos theta whole square plus 4 sin square theta. This is what we are getting. Now again, it is slightly similar to the previous question, because here also it is saying that real part is 1 by 5. In the previous question, the real part was 0. So the approach is somewhat similar. So the real part here is now, therefore, this real part 1 minus cos theta by 1 minus cos theta whole square plus 4 sin square theta is equal to 1 by 5. Now this you have to solve and find the value of theta. After you will be able to find the value of theta, then the question does not have nothing more to do. You just have to find this integral. So note till here and find the value of theta, then we'll discuss it. So if you proceed here, if you see like what will be the value of theta here basically. So this will become 5 into 1 minus cos theta is equal to 1 minus cos theta whole square plus 4 sin square theta. This is what we will get. And this will be 5 into 1 minus cos theta is equal to 1 minus cos theta whole square. And sin square theta is 1 minus cos square theta. So this is how we write it. So this is 5 into 1 minus cos theta is equal to 1 minus cos theta whole square plus 4. 1 minus cos square theta can be written as 1 minus cos theta into 1 plus cos theta. This is how we can write it. So this is, we are simplifying the trigonometric equation and finding the solution of this trigonometric equation. So this will become 5 into 1 minus cos theta is equal to, and 1 minus cos theta we can take common. 1 second, once. Yeah. So 5 into 1 minus cos theta into 1 minus cos theta whole square, 1 minus cos theta we take common. It is 1 minus cos theta plus 4 into 1 plus cos theta. So one solution could be, we can't cancel 1 minus cos theta. This is a common mistake which students do. They say let us cancel 1 minus cos theta. But this could be a solution also. That is 1 minus cos theta could be equal to 0 also. And then left hand side and right hand side will become equal. So one solution is that 1 minus cos theta is equal to 0. And another solution is that if we cancel 1 minus cos theta, so 5 is equal to 1 minus cos theta plus 4 cos theta. So from here we will get 4 plus 1, 5 cancel. Cos theta is equal to 0. So from here we get cos theta equal to 1. And from another one, we get cos theta equal to 0. So these two solutions we are getting, right? So first you can write it till here. Okay, let us see further. So cos theta is either 1 or 0. And we can cross check that whether we can take it as 1 or we can take it as 0. So one thing is that if you see the interval of theta, it is given between 0 to pi. It was 0 to pi, right? 0 degree to 180 degree, and 0 degree and 180 degree were not included. So at 0 cos theta is 1. At pi cos theta is -1. So 1 and -1 are not included. Pi by 2, which will be just in between, it will be 0. So you can take this value of cos theta, but this value you can't take because cos theta is equal to 1 when theta is equal to 0 and theta is equal to 0 is not included. So theta is equal to pi by 2 is included. So theta is equal to cos theta equal to 0 you can take. Now it says the value of 0 to theta sin x dx. So 0 to theta, which means pi by 2 sin x dx we have to find out. So integral of sin x is minus cos x. And this is 0 to pi by 2. And this will be minus cos pi by 2 plus cos 0. Cos pi by 2 is 0. And cos 0 is 1. So we get the final answer as 1. Now let us see one question which is based on argument and modulus. So the question is like this. If Z and omega are two complex numbers such that mod of Z omega is equal to 1 and argument of Z minus argument of omega is equal to 3 pi by 2. I will revise you what is the argument and what is the mod. Then argument of 1 minus 2Z conjugate omega by 1 plus 3Z conjugate omega is, options are given, pi by 4 minus 3 pi by 4 and minus pi by 4 and 3 pi by 4. So if you just let us have a small revision of argument and modulus, then we will come to this question. So modulus was that if there is a complex number x comma y, which is x plus iy, then its distance from origin is mod of z, which is root over x square plus y square. This is mod of z, okay? In polar form, we also say that this mod of z is equal to r And this complex number z in that case is written as r cos theta plus iota r sin theta. That is, x is being written as r cos theta. This is r, this is theta, this is x, and this is y. And this y is written as r sin theta, this y. So mod z is either root over x square plus y square, or mod z is equal to r. And argument of z is equal to theta. But here there is some condition also. Like what happens that in different quadrants, we have different values of argument. Like theta we find out as tan inverse of mod of y by x. And then in the first quadrant, argument of z is equal to theta. In second, argument of z is pi minus theta. In third, argument of z is minus pi plus theta. And in fourth, argument of z is equal to minus theta. So this is about argument. So you just write it down, then we will discuss this question. There are few properties also, but if there would be any use of properties, we will discuss in between. Right now, we are more concentrated on the definition here. Okay, so I hope you have written this the small part. Now this is the question here. So there is modulus here also, there's argument also. There is conjugate also. Conjugate is if z is equal to x plus iy. What is conjugate? You can write that also. If z is equal to x plus iy, then conjugate of z, that is z bar, is equal to x minus iy. So this is the small definition of conjugate. Give it a try. I'm coming back in 5 minutes. I just need 5 minutes. So just give it a try. Okay. So I have given you enough time. Actually, I forgot about the prayer. So I went for the prayer for 5 minutes. So I gave you enough time to practice this question also and give it a try. Now let us discuss it. So what it says, let us see now. If Z and omega are two complex numbers such that Z omega mod is equal to 1, okay? And argument of Z minus argument of omega is equal to 3 pi by 2. That is also fine. Then argument of 1 minus 2 Z conjugate omega by 1 plus 3 Z conjugate omega is. Okay. So we can take Z omega mod is equal to 1. First of all, this is what is given to us. So we can, by property of modulus, we can write it as Z omega into Z mod into omega mod is equal to 1. And let us call Z mod as R1, omega mod as R2, and these are 1, where Z mod is equal to 1, Z mod is R1, omega mod is R2. So we write it like this. Now next is argument of Z minus argument omega is 3 pi by 2. So argument of Z minus argument omega is equal to 3 pi by 2. This is what is given. So let us call argument of Z as theta and argument of omega as alpha. So this is 3 pi by 2, theta minus alpha, where argument of Z is equal to theta and argument of omega is equal to alpha. So we write it like this. Fine. Now, 1 minus 2Z conjugate omega by 1 plus 3Z conjugate omega. So 1 minus 2Z conjugate omega by 1 plus 3Z conjugate omega. This is what is argument of this is being asked. Fine. So 1 minus 2 Z conjugate will be R1 e to the power. Z is argument of Z is theta. So argument of Z conjugate will be minus theta, minus I theta, right? We can write it like this. Z is equal to R1 e to the power I theta. So Z conjugate is equal to R1 e to the power minus I theta. This is its Euler form, or the polar form is changed into the Euler form. Omega is R2 e to the power I alpha. And this divided by 1 plus 3 Z conjugate is R1 e to the power minus I theta into omega is R2 e to the power I alpha. So we write it like this. So this is 1 minus 2 R1 R2 e to the power minus I theta minus alpha by 1 plus 3 R1 R2 e to the power minus I theta minus alpha. So we can write, okay, let us write it like this. Okay. First write till here. Okay, so I hope you have written it till here. Now R1, R2 is equal to 1. That already we saw here, that R1 into R2 is equal to 1. So we can say that R1, R2 here also is 1, here also is 1. This will become 1 minus 2 e to the power minus I theta minus alpha by 1 plus 3 e to the power minus I theta minus alpha. Now what is theta minus alpha? That also we know. Theta minus alpha is equal to 3 pi by 2, right? So we can write it as 1 minus 2 e to the power minus I 3 pi by 2. And this will be 1 plus 3 e to the power minus I 3 pi by 2. Now what is e to the power minus I 3 pi by 2? So e to the power minus I 3 pi by 2 means cos 3 pi by 2 minus I sine 3 pi by 2. So cos 3 pi by 2, cos 270 degree is 0. And sine 3 pi by 2 is minus 1. So this will become plus I. So this is I. So therefore we can say that this is equal to 1 minus 2I by 1 plus 3I. We can write it like this. So first write till here. Okay, so if you proceed further, so this implies that this given expression argument of which we want to get is argument of this one. Okay, so argument of 1 minus 2I by 1 plus 3I. This is what we need to find. This is what is being asked in the question. So 1 minus 2I by 1 plus 3I. So what we do, we multiply by 1 minus 3I in the numerator and in the denominator. That is actually the conjugate of the denominator. Then only we will be able to solve it. So this will become 1 and this will be plus 6 iota square, which will be minus 6. So 1 minus 6 will be minus 5. And minus 3 iota minus 2 iota is minus 5 iota upon 1 minus 9 iota square, which will be 1 plus 9, 10. We can write it like this after calculation. Denominator a square minus b square we applied. Numerator we multiplied the terms with their terms. So this is the argument of minus 1 by 2 minus 1 by 2 iota. Now what is the argument of minus 1 by 2 minus 1 by 2 iota? So if you just see the definition of argument, theta is equal to, let us not call it theta because theta we have already taken something. Suppose delta is equal to tan inverse of mod of y by x, that is minus half by minus half. That is tan inverse of 1, which is pi by 4. Now the quadrant in which this lies, minus half, third quadrant. In the third quadrant, as I told you earlier here, it is minus pi plus theta. What is the argument? Argument is minus pi plus theta. So this is the argument. So in the third quadrant, if we talk about, it is minus pi plus theta. So argument will be minus pi plus theta, and theta is actually delta here. We have taken delta minus pi plus pi by 4. That will become minus 3 pi by 4. So this is the final answer which we will get. Minus 3 pi by 4, which is option B. Now you can write it. So let us come to the next question. If anyone is having doubt in any step, or it is not clear, or you have forgot something, then you can ask. I will revise it. I will make it more clear to you. Okay, so please don't be silent in that case. Let us see the next question. The next question says the imaginary part of 3 plus 2 root over minus 54 under root minus 3 minus 2 root over minus 54 under root can be minus root 6 minus 2 root 6 6 root 6. So you have to just little bit of think that what pattern is this becoming a perfect square of something? And similarly, is this becoming a perfect square of something? Then in that case, a square and root will cancel each other. So just think about it. Let me give you a hint. If it is 3 plus 2 root over minus 54. So one thing you can do, you can write root 2 root over 54 iota, because root over minus 1 is iota. Now just think that root over 54, this 2 is fine. 2ab is there in the formula of a square plus b square plus 2ab. So this 2ab, 2 is needed. Now point is that what should be a and what should be b? Can we take some a and b like this? So what we can do, we can take uh, root over 9 into root over 6. Okay, like this iota. So this actually will after a little bit of thought process, this will come in your mind that let us take one number as root over 9. This is A, and another number as root over 6 iota. So when you will multiply, it will become root over 54 iota. 9 6 is 54. What is the benefit of taking like this? You could have taken root over 27 into root over 2i also. But why we have taken it like this? Because this is 3 here. And this is root over 9. So root over 9 square when we will do plus root over 6i square when we will do. So root over 9 square will be 9 and root over 6i square. Root over 6 will be square will be 6. I square will be minus 1. So 9 minus 6. 9 minus 6 will be 3. So this 3 will be obtained if you make the arrangement like this. So root over 9 square plus root over 6 iota square plus 2 root over 9 root over 6 iota, which will become the formula of root over 9 plus root over 6 iota whole square. A plus B whole square. So just you can write it like this. So write it down and then think about the another one also, next one also. You can also see the next one clearly. Yeah, there is also an announcement which I made in the starting of the class. So I'm again reminding those who have joined little late that today there is no physics class. We have maths class of little long duration. So right now it will be till around 6:30, from 5 to 6:30. Then there will be an half an hour break. I'm talking about Indian time. So you can, if you are from Saudi, you can subtract 2.5 hours from that. If you are from UAE, you can subtract 1.5 hours from that. So first class is from 5 to 6:30 of maths, which will complete in soon. And then there will be a half-hour break. And then 7 to 8 will be next 1 hour class of maths. So there will be a half-hour break in between. So 7 to 8 means that the next time would be for Saudi students, it will be 2.5 hours before 7, that is 4:30 to 5:30. And for UAE students, it will become 1.5 hours before. So it will become like 5:30 to 6:30. So if you see students here in this case, if 3 plus 2 root over minus 54 is root 9 plus root 6 iota whole square, what will be 3 minus 2 root over minus 54? Isn't it come out to be root 9 minus root 6 iota? Iota is not inside square root, it is outside the square root. It is minus root 6 iota whole square. So if you take under root, so under root of 3 plus 2 root over minus 54 is equal to root 9 plus root 6 iota square under root, right? Minus 3 minus 2 root over minus 54 will be root 9 minus root 6 iota whole square under root. This will become like this. So square and root will cancel. Here it will be plus minus both. But here it is, no, not both. It is only plus. So it would be root 6 plus minus both is possible there actually, because plus square is also positive, minus square is also positive. So in that case, you can take plus minus both. Let us now take only plus. So root 9 plus root 6 iota. And here root 9 plus root 6 iota. So it will become 2 root 6 iota. So if we observe the imaginary part of this, so the imaginary part of this will be equal to, imaginary part is 2 root 6. So is there any such option? It is minus 2 root 6. Yeah, so minus also we can take. So what is the point here is, we can take plus minus both here also, and here also plus minus both. This, oh, sorry. This is minus root 6 iota. I missed this part. This is minus root 6 iota. So in that case, what will happen? So if we take plus minus both, let us take both, plus minus both. So plus minus root 9 plus root 6 iota, then minus, and then plus minus root 9 minus root 6 iota. So this would become plus minus root 9 plus minus root 6 iota, and minus plus root 9, and then this would become plus minus root 6 iota. Fine. So plus minus root 9 and minus plus root 9 will cancel. And plus minus root 6 iota plus minus root 6 iota will be plus minus 2 root 6 iota. So I have done both the things in one step. If you want, you can do for minus separately, for plus separately. You will get the answer like this. So you can get either 2 root 6 iota or minus 2 root 6 iota. So in this situation, the answer which is matching is minus 2 root 6, which is option B. Okay. So we can take plus also or minus also, because if we take only plus, our option is not matching, because option is not given in terms of that answer. But if it was given in that term, in term of that answer, then it was okay. You can write it now. So we keep it till here in today's class, and not in today's class, in this particular first session of the maths class. And after 35 minutes, okay, just after 35 minutes, we will start the next session, and that will be of 1 hour. So till then, we will have a break, and I'm concluding the class for this session. Next session is after 35 minutes, then we'll restart it. Or we can also do one thing. We can keep it on 1 second. Let me confirm that should we restart?